Hey gang, it's me, Dr. B. And for today, we're gonna be doing the iodine clock experiment. So as you probably have seen with your materials, you've got some prep on how to make all your solutions for the iodine clock reaction. And so what I have here is the actual final, when you make solution A and B, I've got those all prepped. And so what I'm gonna show you is what happens after you mix everything together. So let's make it happen. All right, let's make sure that we're focused. We've got our solution. Nope. Okay, this is our solution right here. This is currently solution B, and what I'm gonna do is add solution A. So here we go. Voila. And what we're gonna do also is we're gonna give this like a little bit of a swirl, and then we're gonna look at everything. We're gonna let the reaction proceed. Now, in this reaction, what I've done is for solution A, I have 3 milliliters of vitamin C, the stock solution. I've got 5 milliliters of iodine, and I've got 22 milliliters of water, so that my total volume is 30 milliliters. For solution B, I have 3 mils of hydrogen peroxide, 3 mils of liquid starch, and 24 milliliters of water. Now, when mixing everything together, I only took 5 mils of each of the 30 milliliter solutions and mixed that together. The reason B is so that you have the ability to then do a triplicate run with the same solution A and B that you prepared, so that you can be a little bit more efficient. Now, for the solution I just mixed together, this should take about 5 minutes. So we've still got a couple minutes to go. While you're doing your experiment, what you'll probably want to do is you can prep some other concentrations if you like. You can also, in the meantime, definitely be running your triplicates all at the same time so that everything is running smoothly. And you can make sure that what you see in the first one is what's going to happen in the later ones. And for your experiment, you're going to be you'll be testing how different concentrations of iodine affect your reaction time. You're going to look at different concentrations of hydrogen peroxide, and also look at how ascorbic acid may affect your iodine clock reaction, so that ultimately you're collecting information that will help you with determining the reaction order. And if time permits, we're going to look into what to do if you change temperature, so that you perhaps can get the activation energy. Okay, now as you see, my solution is still clear, and that's okay. I mentioned it's going to take about 5 minutes for this to progress and for us to see a color change. And I'm making this video so that you can see what that color change may look like when you do your own experiment. And as you see, it's currently just a clear, cloudy solution, and that's in part because of the liquid starch. It is a white, cloudy solution, but that's okay. For the ascorbic acid concentration, when you're making that's the vitamin C solution, you're going to want to have two vitamin C tablets. They're 500 milligrams per tablet. You're going to crush those up finely. I recommend you use either filter paper or use one of the coffee filters and crush the tablets inside of those so that you don't lose any powder. And then you're going to add 60 mils of water and dissolve all of the vitamin C tablets in the 60 mils. So you have 1,000 milligrams of vitamin C in 60 milliliters of water. And then after you do the dissolution of your vitamin C tablets, make sure that you separate out any undissolved vitamin C by running it through a coffee filter. Perhaps if there's no tears in the coffee filter used to crush up the vitamin C tablets, you can use that. And as you're doing the filtering, you may see that there's a pool of water and it's really tough for the water to exit the coffee filter. It is okay if you pinch the pool so that you apply a little bit of pressure to force the vitamin C solution to exit the coffee filter a little bit quicker. That's okay. Okay, looking at the time right now, I think we got about another minute or so until we see that color change, which is very exciting. And I'm very hopeful that you all get to see a nice color change and you get to have a lot of fun with kinetics. Yes. All right. Let's see, are there any other items that we need to talk about while this is going on? Feel free to ask questions. Dr. B, you're recording. Yes, I know. I was trying to pretend that this was like us being in person, but that's okay. Now, as you're doing your reaction, the whole reason you need to vary iodine and hydrogen peroxide concentrations is so that you're able to determine the reaction orders. Those are super important. And what do you know? Hey, there's a color change that's starting to happen right now. You see how the top is starting to turn black, and then the rest is now starting to turn that yellow, and the blackness is seeping downwards. What's going to happen most likely is you'll see a color change. It may happen in one part of your solution and then migrate to everywhere, but what we're going to focus on is when we start to see a color change, because that indicates that you have fully exhausted all the ascorbic acid in solution. And as you see now, after about 30 seconds, the entire solution turns black. All right, so thanks a lot for tuning in. Feel free to ask me any questions, but now you have a visual representation of what the iodine clock solution, the iodine clock experiment should look like when you run it. I wish you all the best of luck with this experiment, and I'll see you all soon.